Okay, so I'm going to show you how to do this in MATLAB. Uh, it's actually quite similar. And if you have questions about this, Lawrence in the back, with his hand raised, is the person to talk to. He developed all of this. In fact, he's the lead developer of MatNWB and can answer any MatNWB questions you might have. All right, so uh, in MATLAB, we want to have the same capabilities. Basically, we want to be able to chunk, compress, and do iterative write. Those are the main things. And then also access different compression algorithms. So I'm going to walk through the syntax for doing that and how it's slightly different from PyNWB. So first of all, let's just generate some random numbers. And then if you want to compress this data, all you have to do is call types.untyped.datapipe and then pass the data argument as your data, right? This will create a data pipe object. So now instead of having a standard MATLAB array, you have a data pipe object which contains information about how to store this data set on HDF5. Now, by default, this will chunk your data. So we have this set up so that you don't even have to specify anything. If you just do this, it will kind of decide on a reasonable chunking strategy and run gzip. And if you don't want that, then you'll have to manually set the arguments. So in terms of the arguments available, here they are. They're similar to the arguments available for Python because basically what both of these libraries are doing is passing these arguments to the underlying HDF5 library. So we have max size. So this sets the maximum size of the data set. So it's possible to create a data set and have it be of a certain size and then say the max size is bigger than that, which allows you then to write to the data set later. If you don't manage this property, then the max size will automatically be set to the size of the data set as it is written, and it won't be expandable. Data, of course, it's the data that you want to write. Axis is used if you want to increment to this data set. So if you want to, I'm going to run at the end a little demo about writing incrementally, and this is the axis over which you're iterating when you write incrementally. Data type is pretty self-explanatory. It's automatically inferred from the type that you supplied, but you can change it if you want to. Chunk size indicates the chunk size, which then will tile across the data set the chunks. Compression level is so with gzip, you can choose between 0 and 9. 9, it takes a long time to run, and it is the most compressed. But generally, you don't get a whole lot better performance with 9 than you do with like 3 or 4. So that's generally what we recommend. Default is 3, which is also the default that MATLAB uses when it saves data. So that's probably a pretty good choice. And offset is something that you use when you're appending data. You probably won't have to mess with that property. All right. So let's talk about if you want to chunk an actual data set within an MWB file. So we'll write a very simple MWB file where we're just instantiating the MWB file object, and then we want to add a time series, and we want the data of this time series to be chunked. So, okay, we create some data here, which is random numbers, and we're going to wrap this in data pipe, and then we will create a time series object, set the data value to this data pipe object, and then unit. Actually, I'm pretty sure we need rate or starting time here, so actually I don't think this would work. You wouldn't need to add rate or starting time too. But in general, the way we're doing the chunking would work. So then once we have this object, we can set this to acquisition and then export the MWB file. And this will create an MWB file that has this data set chunked. Well, once we fix the rate and starting time issue. Okay, so what if you don't want the default settings of chunking? What if you want to change the shape of the chunks and how it tiles across the data set? That's possible too. You just change the chunk size argument. And here I'm also going to alter the axis argument. Now another important feature of this advanced data I/O is if you have too much data to fit into RAM and you want to piecewise read your data and write it, right? So instead of having the data chunk iterators as you do in Python, you do that manually here. So let's say we're going to just randomly generate data here. So again, we have an MWB file. We create a data pipe. Here it's just data part 1 that we're going to add. So this is I guess, a 10,000 length array of random integers, but our total is 40,000. But we're just loading in 10,000 for now. So we're going to populate the data with an array that's 10,000 long, but we're going to say that the full data set size is 40,000, and that we want to concatenate it along the first axis. Now we write this time series just the first segment, just the first quarter of the data, and we set the acquisition and then we export it. Now we can read that file back using MWB read, and then we can generate new data. And if you do mwb.acquisition.get timeseries.data, you have this append method, which allows you to add data to this data pipe. So this code will fetch the data pipe, and then this here will add data to that data pipe. And it's going to add along the dimension that you listed here with axis 1. Okay, and then here's just an example of seeing that all the way through. So yeah, you're able to do both of these methods combined, right? So you're able to do chunking and compression, set the parameters, and do iterative write. And that's generally what you are going to want to do for really large data sets. Okay, and then let me just also, so by the way, if you want to access these tutorials, just go to MatNWB, and it's in the README right here. I just showed you the advanced data write, and then here is the using dynamically loaded filters. Okay, so just like in Python, the HDF5 comes with gzip, but it also has the ability to use other compression algorithms, and some of them work really well. In particular, ZSTD, in our experience, works quite well. The downside of ZSTD, so the upside is that it tends to be fast on read and write, and it tends to give good compression ratios. So it performs well in a lot of different scenarios. The one downside of it is it doesn't come with HDF5 by default. You have to install it separately, which means you would have to install it to write the data, and anyone else who wants to read the data also has to install this. Okay, so how do you do that? First, let's talk about reading. So you want to be able to install ZSTD, and it turns out that the easiest way to install it is through a Python package. Now, I know we're in MATLAB, and if you want to stay in MATLAB, that's okay, but you just have to do one line of pip installing this. It turns out they did a lot of work in HDF5 plugin in the installation scripts to manage all sorts of different operating systems and install these compression algorithms. So we tried a bunch of different methods for getting these installed on your computer, and trust me, this is by far the easiest method. So you'll need to pip install HDF5 plugin. We're not going to use Python any more than just these few lines, but that's what we need to do. And then we need to get an HDF5 plugin path. So these are, by the way, this is for Linux and Mac. I'll talk about Windows in a second. An HDF5 plugin path, and all you need to do is execute these lines where you're basically calling HDF5 plugin and printing out wherever it installed these plugins on your computer. And that you're going to assign to this environment variable HDF5 plugin path. Now, through that same terminal, you want to launch MATLAB. And I don't know exactly where MATLAB is going to be on your computer. It's going to be something like this, probably in applications, and then the version of MATLAB/bin/MATLAB. If you launch it from the terminal where you've defined this HDF5 plugin path, then MATLAB will know where to find those plugins, and it will be able to use them when reading an HDF5 file. If you're on Windows, it's very similar. You want to pip install and then get the HDF5 plugin path, but you can set this environment variable manually within the windows of MATLAB on Windows computers. So you go into in system properties, and then you can find environment variables, and you can add an environment variable that it can then find. And then if you're in Windows, you should restart MATLAB so it uses that environment variable. And that's it. Once you've done that, MATLAB now has access to these plugins and can read data that are using the compression algorithms that are supported by HDF5 plugin, including ZSTD is probably going to be the most popular, but also a lot of these other compression algorithms which can be useful in certain types of situations. So there's nothing special that you need to do inside of your MATLAB code itself. HDF5 under the hood will be able to find the plugins if it just has that path to where you've installed them outside of MATLAB. Now the question is, how do you write data if you want to write with a dynamic filter, and which means a filter that's not included, basically not gzip, something other than gzip. So you can do that. By the way, this will only work for versions of MATLAB greater than or equal to 2022A. So here's an example of how you would do that for ZSTD. You can import these properties. So you're importing a dynamic filter, and shuffle. Okay, so here we're saying, okay, give me a dynamic filter with the Z standard. And then you can set the parameters of this. So ZSTD has a level of compression similar to gzip, where you can say, okay, I want it to be less aggressive or more aggressive. Just like gzip 3 or 4 tends to be the sweet spot for where you get good compression performance without a lot of I/O penalty in the speed of read and write. You can also stack multiple filters. So you can do, for instance, a shuffle, a bit shuffle, and then do ZSTD. So here's how you would do that. Here's how you create a dynamic properties array that is a list of the filters you want to do. So just like Python, it will consecutively apply these filters on write and then do the opposite on read. So then once you have this dynamic properties, it's pretty straightforward. So you again use this data pipe object, you have your data, you set it to some data values, you use this keyword filters, and then you set it to this array of these filter objects. And then from there, it's exactly the same. Okay, so you write a time series, create an MWB file, set a time series, export it. And then if you load this in certain programs, such as HDFView, and you go to the data that you've written, you can see here that it is chunked and that it is using the ZSTD Z standard compression algorithm. And there you go. This is a proper MWB file. You can upload it to Dandy and do whatever else with it. Just be aware that anyone who wants to read this, whether they're using Python or MATLAB, will need the advanced plugins in order to read this file. All right, any questions?